Density is defined as the amount of matter in a given unit of volume. If you look at A, notice that there is less matter in A than in B. Assuming that the containers have the same volume, there is less matter in A, meaning that the density of A would be less than the density of B. The more matter in a given volume, the greater the density. The formula for density is given as density equals mass divided by volume. Let's now solve some problems. Problem number 1. What is the density of a piece of cork which has a mass of 0.65 grams and a volume of 2.71 cubic centimeters? Density is equal to mass divided by volume. In our problem, we see that our piece of cork has a mass of 0.65 grams and it's in 2.71 cubic centimeters of the cork. We don't leave this as our answer. We're going to actually divide. And when we divide, we get 0.24 grams per cubic centimeter. This means that every cubic centimeter of cork has a mass of 0.24 grams. Let's look at problem number 2. Problem 2A. A piece of lead. Now, wouldn't you expect that lead would have a greater density than cork? Let's make sure that that's what we get as an answer. A piece of lead with a mass of 34.2 grams occupies 3 cubic centimeters. What is its density? Density is equal to mass divided by volume. In this problem, lead has a mass of 34.2 grams divided by 3 cubic centimeters. When we divide, we get lead having a density of 11.4 grams per cubic centimeter. That means every cubic centimeter of lead has 11.4 grams in it. Let's look at problem B. In problem B, we have a piece of lead occupying a volume of 4 cubic centimeters. What is its mass? To solve any problem in chemistry, the first thing we write down is the given. In this problem, 4 cubic centimeters is the given. It's the volume. Now we want to change volume to mass. Let's look at our density. We already calculated that every cubic centimeter has 11.4 grams in it. Doesn't this look like a conversion factor? If I put it in 11.4 grams per cubic centimeter cancels out, and I wind up with an answer of 45.6 grams. 4 cubic centimeters of lead must have a mass of 45.6 grams. Let's now do problem C. Problem C. A piece of lead has a mass of 22.8 grams. What volume does it occupy? To solve any problem in chemistry, the first thing that we write down is the given. The given in this example is 22.8 grams. Now we need to put in a conversion factor. Can we not write 11.4 grams per cubic centimeter upside down so that we have 1 cubic centimeter over 11.4 grams? Notice in this case that grams cancels out. 22.8 times 1 divided by 11.4, we're going to get a volume of 2 cubic centimeters. That means a piece of lead that has a mass of 22.8 grams must occupy 2 cubic centimeters. Let's do problem number 3. A sample of copper has a density of 8.92 grams per cubic centimeter and occupies a volume of 8 cubic centimeters. What is the mass of the sample? In the majority of the problems, density will never be your given. The density is going to always be your conversion factor. Let's use 8 cubic centimeters as our given. 8 cubic centimeters. Now, we're going to use our density as it is, 8.92 grams per cubic centimeter, so cubic centimeter cancels out. We get an answer of 71.36 grams. Unit analysis is a great way to solve density problems. Let's look at question number 4. Question number 4 says, what is the volume in milliliters occupied by 880 grams of benzene if the density of benzene is 0.88 grams per milliliter? Remember, we're not going to use the density as our given. It's the conversion factor. Instead, we're going to begin with 880 grams of benzene. 880 grams of benzene, and we can abbreviate. And now, how are we going to put the density in so that grams cancels out? Can't we write it like this? 1 milliliter over 0.88 grams of benzene. Grams of benzene cancels out, and we get 1,000 milliliters. Let's do one more problem. Problem number 5. What is the mass occupied by an object whose density is 1.5 grams per cubic centimeter and whose dimensions are 0.5 by 1.5 by 1? We want to find the mass. That means we have to change the dimensions into volume. Length times width times height. When we multiply these 3 together, we come up with 0.75 cubic centimeters. That's our given. To find the mass, we're going to put in our density, and we can put it in as written because then our cubic centimeters are going to cancel out, and we wind up with 1.125 grams. Let me help you get started with question number 6. The radius of a hydrogen nucleus is 1 times 10 to the minus 3 picometers. Its mass is 1.67 times 10 to the minus 24 grams. What is its density in grams per cubic centimeter? Density is equal to mass over volume. We have that the mass is equal to 1.67 times 10 to the minus 24 grams. Well, now we have to find the volume. Notice that I gave you the radius. The important thing here, though, is that I gave you the radius in picometers. I'm asking you for the density in cubic centimeters. So before you plug it into the volume formula, 4/3 times pi times r cubed, you must change picometers to centimeters. Plug that in for your radius, multiply that by 4/3 pi, and that's your volume.